अब डिवाइस कौन से देख,
एटी है एटी चूज कर
डिवाइस पे क्लिक करना, माइक्रोफोन, हाँ
Yep.
ओके बस।
सही है।
दे तो रहे बार
तेरा तो लाल ही कर दिया बे एकदम गजब।
डिवाइस कौन से देख,
एटी है एटी सही।
डिवाइस पे क्लिक करना,
हम लाइव है।
Yep.
ठीक है, ये लिंक भेजे इसका, ये वाला। ठीक है, और तेरे जब तू करेगा ना प्रैक्टिस, देख इधर बताता हूँ तेरे को, छोड़ से।
दे तो रहे बार
तेरे को बस मैं की दूंगा एकदम गजब।
डिवाइस कौन से
55 पे तुझे क्या करना है, यहाँ सेटिंग में जाना है,
डिवाइस पे क्लिक करना,
लाइव है, आउटपुट में जाना है, ये लिंक भेजे इसका, आउटपुट का स्ट्रीम, यहाँ पे जाके बस ये चेंज कर देना, और कोई ब्राउजर पे कोई विंडो ओपन नहीं करनी चाहिए। ठीक है, सेकंड चीज़ ये है कि इस पे इसको हमेशा म्यूट रखना।
डिवाइस कौन
किस
से
चीज़ को?
तुझे क्या करना है, यहाँ
मेरा
सेटिंग
स्पीकर।
डिवाइस पे क्लिक
इसको म्यूट रखना हमेशा,
Yep.
आउटपुट में जाना है,
और ये सारे फालतू फालतू चीजें जितनी चल रही है बैकग्राउंड में
यहाँ पे
सारी
जाके बस ये जब करेगा ना, और कोई ब्राउजर पे कोई विंडो ओपन नहीं करना, सब उड़ा दियो। ठीक है, सेकंड चीज़ लड़की आ रही है, इसको हमेशा म्यूट रखना।
डिवाइस कौन
किस
से
चीज़ को?
तुझे क्या करना है, यहाँ
मेरा
सेटिंग
स्पीकर।
डिवाइस पे क्लिक
इसको
करना,
म्यूट रखना, 100% आउटपुट में जाना है,
और ये सारे फालतू फालतू चीजें जितनी चल रही है बैकग्राउंड
यहाँ
में
पे
सारी
जाके बस ये जब करेगा ना, और कोई ब्राउजर पे कोई विंडो ओपन नहीं करना, सब उड़ा
मैक्सिमम तो OBS ही खा रहे हैं।
सेकंड चीज़ लड़की आ रही है, इसको हमेशा म्यूट रखना।
डिवाइस कौन
किस
से
चीज़ को?
तुझे क्या करना है,
तो चली
मेरा
गई
स्पीकर।
डिवाइस पे क्लिक करना,
देख लो अभी जब तू
और ये
आके
सारे
प्रोग्रामिंग
फालतू
करेगा,
फालतू चीजें जितनी चल रही है बैकग्राउंड
यहाँ पे
में
जाके बस ये जब करेगा ना, और कोई ब्राउजर पे लिंक कॉपी कर लिया था,
मेरा कभी भेज रहा हूँ।
कर ले, अब भेज दे, और वो टैब खोल लियो जो बताया था तेरे को। ठीक है, ऑर्गेनाइज। शुभम को भेज दियो लिंक, राणे को, ठीक है।
Okay. Hey guys, welcome to this live session by IntelliPad. So before I start off, just give me a quick confirmation if I'm audible or not, and also let me know if the screen is visible. Right. So you might have come across the term R programming quite a few times, and numerous questions would have popped into your head. Is it just another programming language? How is it different from other programming languages? And is it really hard to learn R programming? So today we've just come up with the right video so that you can start your journey in the field of R programming. So let's have a look at the agenda. So we'll start off by understanding what exactly is R language. Then we'll work with variables in R. After which we'll look at the different types of operators. And then we'll learn about objects. And finally, we'll work with flow control statements. So what exactly is R? So R is a language developed by statisticians for statisticians. So if you want to do any sort of statistical analysis, your go-to language should be R. Now R is also a great tool for visualization. So R provides numerous packages such as ggplot2 and plotly so that you can create stunning visualizations. Now R is an open source cross-platform comparable software. That is, it's just plug and play. All you have to do is install R once and then you can start having fun with it. So, since R is an open source software, you can even modify the code and add your own innovations to it. And being cross-platform compatible, you can run the same R code on different operating systems. Now, the best point about R is it is a Turing complete language. That is, you can perform any task which a Turing machine can. And this is what makes R such a powerful language. So, whatever the task is, whether it is statistical analysis, machine learning, or visualization, you can do it all with this language called as R. So now let's actually go ahead and install R and RStudio into our systems. So we can download R from the site cran.rproject.org. Right, so we have different versions of R. So if you're using a Linux system, then you can download R for Linux. If you're using Mac, then you can download R for Mac. If you're using Windows, then you can download R for Windows. And since I'm using a Windows system, I'll download R for Windows. I'll click over here, install R for the first time. And this is the latest version of the R, guys. So R 3.5.1 is the latest version of R. So I'll click on this. So the download has started. And since I've already installed R, I'll just go ahead and cancel this download right here. Right, now after installing R, we would also require an IDE so that we can perform our tasks in an easier way. So one such IDE is RStudio. So RStudio is an open source free software with which we can perform our tasks quite easily. So we can download RStudio from the site rstudio.com. So I'll click on download RStudio over here. So we have this free version, RStudio desktop open source license, and I'll click on download again. And again, we see that we have different versions of RStudio. So if you're using a Windows system, you can download R for Windows. If you're using Mac, you can download RStudio for Mac. Same for Ubuntu and Fedora. And since again, I have a Windows 10 operating system, I'll download RStudio for Windows 10. Right, so the download would start. And since again, I already have RStudio installed on my system, I'll go ahead and cancel this installation. Right. So now after installing R and RStudio in my system, let's go ahead and understand what exactly are variables in R. So simply put, a variable is just a temporary storage space. So let's understand what exactly is a variable with this example over here. So let's say we have a cart, and this cart would be a temporary storage space, and we have an apple with us. So I decide to store this apple inside this cart. Now after some time, I decide to replace that apple with a banana. Again after some time, I decide to replace that banana with a mango. So this is the basic idea behind variables, guys. So it is a temporary storage space where we can keep on changing the values again and again. Right. So now that we've understood what exactly are variables, let's go ahead and implement these variables in RStudio. So what I'll do is I'll create a variable by the name of fruit, and I will use this assignment operator and give a value to this. So let's say the value which I give to this variable would be mango, So let me copy this and let me paste it over here. Right, now let me print fruit. So what we get is mango. So the value which is stored in this fruit variable is mango. Now I will go ahead and change the value. So this time the value which I'd be giving to this is apple. So I'll select this, I will paste it over here. Now let me print fruit again. Right, so what I've basically done is I've changed the value of fruit from mango to apple. So this is how a variable works. Now similarly, I'll change this value again. So this time I will give the value to be orange. So let me print it out over here. I will print fruit. So this time again, the initial value is apple and I have changed that value to orange. So this fruit over here is a variable and the original value which this variable held was mango. After which we change the value to apple and then going ahead we change this value to orange. So now that we've understood what exactly is a variable, now let's go ahead and understand what are data types. So every variable in R is associated with a data type. So let's start off with numeric data types. So a variable can hold numeric data types such as 5, 1000 and -33. A variable can also have character data types such as Z, Sparta and Hello World. Then the next type of data is logical. So there are two logical values basically which are true and false. And then finally we have the complex data type. So this what you see over here, this is the complex data type. So this is the real part and this is the imaginary part. So 2 plus 5i, 30 minus 30i and minus 100.47i. These are nothing but complex data types. Right, so let us go ahead and work with these data types in R. So now what I'll do is I will create a new object and name that object to be my obj, and inside this I will give a numeric value. So that numeric value would be 123. Now let me have a glance at the class of this object by using the class function. So I'll type in class over here and I will pass in the my obj object inside this. So you see that the class of this variable is numeric. Now I will change the value inside this my obj object and assign a character value to this. So let's say I assign the value to be this is Sparta. Now let me print the class of this. So class of my obj, and this time I see that the class of this variable has changed from numeric to character. So what we basically understand from this is if we change the value assigned to a variable, the class of the object also changes. Since here the class of this is numeric, the class of the object also changes to numeric. Since this is a character value, the class of this object has also changed to character. Now similarly what I'll do is I'll assign a logical value to this. So my obj equals true. Now let me have a look at the class of this. Class of my obj. So now I see that the class of this object is logical. So now similarly let me give a complex value to this. So my obj equals 5 plus 2i. Now let me have a glance at the class of the object. So class of my obj. So this time the class of the variable is logical. So basically what we can understand from this entire process is if we change the type of the data which we are assigning to the variable, then the class of the variable would also change. Right, so these were data types in R. Now let's go ahead and have a look at the different types of operators. So an operator basically helps us to perform some sort of mathematical or logical manipulation on top of the operands. So these are the different operators which we have. So we have assignment operators, arithmetic operators, relational operators, and logical operators. So let's start off with assignment operators. So as we can see over here, these assignment operators are basically used to assign a value to an object. And these are the three different assignment operators which are available in R. So you can just use an equal to operator, or we can give in the less than symbol and then a hyphen. and this is the third operator over here. So we can give a hyphen and then we can give the greater than operator. Now these are some examples by which we can understand how an assignment operator works. So here I am assigning the value of 10 to this variable x by using this assignment operator equal to. Similarly over here I am assigning this value 20 to the variable y by using this assignment operator. And over here this is basically the reverse assignment operator. So I am assigning this value 30 to this variable z using this assignment operator. Right. So let me go to RStudio and implement these three commands. So what I'll do is I will give in the name of the variable first, which would be x, and I will assign a value of 10 to x. Similarly, I will take in the variable y and I will use the next assignment operator. So first I will give in the less than symbol, next I will give in the hyphen, and then I will give in the value which would be 20. And then finally I will take the third variable, and then finally what I'll do is I will put in the value over here 30, and I will assign this value to the new variable which would be z. So let me print all of these values, x, y, and z. So I have successfully assigned the value of 10 to the variable x, I have assigned the value of 20 to this variable y, and I have assigned this value of 30 to this variable z. Alright. So those were some of the assignment operators. Now let's look at some arithmetic operators. So these arithmetic operators basically help us to perform some basic mathematical operations. So we have this plus symbol over here. So this plus symbol helps us to perform addition. We have this minus symbol over here. This minus symbol helps us to perform subtraction. Then we have this asterisk symbol, and this helps us to perform multiplication between two operands. And then we have this forward slash. So with the help of this forward slash, we can perform the division operation between two operands. So again, let me go to RStudio and perform these basic mathematical operations. And I'll be performing all of these basic mathematical operations on top of the x and y variables. So let's say I want the result when I add x and y. So let's see what do we get. So the initial value of x was 10 and the initial value of y was 20. And when I added these two, I got a value of 30. Similarly, let me add y and z and let me see what do I get. So the initial value of y is 20 and the initial value of z is 30. And when I am adding these two, I get 50. So this was the addition operation. Now let me perform the subtraction operation. So I will subtract y from z. So I will give in the first operand, which is z. Then I will give in the operator, which is the minus symbol. And then I will give in the second operand, which is y. So I am subtracting y from z, and let me see what we get the output to be. So the value of z was 30 and the value of y was 20. And when I subtract 20 from 30, I get a value of 10. Similarly, let me subtract x from z and let's see what do we get. So this time we get a value of 20, and this is because the initial value of z is 30 and the initial value of x is 10, and 30 minus 10 gives us a value of 20. So this was subtraction. Now let me go ahead and perform multiplication over here. So x cross y gives us 200 because x value is 10 and y value is 20, and 10 cross 20 gives us 200. Similarly, let me perform y cross z and let me see what do we get. So here the value of y was 20 and the value of z was 30. So 30 cross 20 gives us 600, and this is the resultant. Now let me perform the division operations. So I will divide z with y and let me see what do we get. So 30 divided by 20 gives us a value of 1.5. Now similarly, I will divide y with x and let me see what do I get. So here 20 divided by 10 gives me a value of 2. So those were arithmetic operators. Now let's understand what exactly are relational operators. So these relational operators help us to compare two operands. So these are the most widely used relational operators. So this is the less than operator, which helps me to compare if the first operand's value is less than the second operand's value. Then we have this less than or equal to symbol. And this helps us to find out if the first operand's value is less than or equal to the second operand's value. And we have this greater than symbol. So this helps us to find out if the first operand's value is greater than the second operand's value. Then we have this greater than or equal to operator. And this helps us to compare if the first operand's value is greater than or equal to the second operand's value. Then finally we have this is equal to operator, and this helps us to find out if the variable 1 is equal to the variable 2. Or in other words, we are just basically comparing if the two variables are equal or not. And then finally we have the not equal to operator. So this is how the not equal to operator looks like. So we're given the exclamation mark and then we basically given the equal to symbol. And with this we try to find out if the operand 1 is equal to operand 2. Right, so again I'll be performing all of these relational operations on top of the x and y variables. So let me find out if x is less than 5. So I get a true value because obviously 10 is less than 20. Now let me find out if x is less than or equal to y. Again I get a true value because 10 is less than or equal to 20. Now let me see if x is greater than y. This time I get a false value because 10 is obviously not greater than 20. Now let me check if x is greater than or equal to y. So this time again I get a false value because 10 is not greater than or equal to 20. Now let me check if x is equal to y. Right, so again I get a false value because obviously 10 is not equal to 20. And finally let me check if x is not equal to y. And this time I get a true value because 10 is not equal to 20. So these were the relational operators. Now let us understand what exactly are logical operators. So these logical operators are used to make a decision on the basis of a condition. And the AND and OR operator are the most widely used logical operators. So let's understand how the AND operator works with this table over here. So we have two conditions, and if the first condition evaluates to false and the second condition also evaluates to false, then the resultant of the AND operator would also be false. Let's take the second case. So over here, if the first condition evaluates to false and the second condition evaluates to true, then also the resultant AND operator would be false. Let's take the third case now. So over here, the first condition evaluates to true, the second condition evaluates to false, and the resultant of the AND operator is false. Now we have the final case where the first condition evaluates to true and also the second condition evaluates to true. So this is the only case where AND operator gives us a true value. So this is because AND will give us a true value only when both of the conditions evaluate to true. In any other case, the resultant would be false. So I'm restating it, guys. So AND operator would give us a true value only when both of the conditions are evaluated to true. Else it will give a false value. Then we have the OR operator. So the OR operator would give us a true value when either of the conditions is evaluated to true. So over here we see that the first condition is false and the second condition is also false. And since both of the conditions are false, we get the evaluated result to be false. Let's take the second case. So over here, the first condition is evaluated to false and the second condition is evaluated to true. And since one of the conditions is evaluated to true, the resultant is also true. Then we have the third case here. The first condition is true, the second condition is false. And since the first condition is true, we get the resultant to be true. And finally, we have both of the conditions to be evaluated to true, and that is why the final result is also true. So let's again head back to our studio and perform these basic logical operations. So what I'll do is, let me give the first condition. So over here, let me check if x is less than 5. Then I'll use the AND operator and I'll give in the second condition and I'll check if x is less than or equal to y. So I get a true value because both of the conditions have been evaluated to true. So here x is less than 5, which means that 10 is less than 20, and I am checking over here if 10 is less than or equal to 20. Now this is also true, and since both of the conditions have been evaluated to true, I get true over here. Now let me perform another operation with the AND operator. So this time, let me give the first condition, which is x is not equal to y. Then I'll give in the AND operator, after which let me give in the second condition. So here I am checking if x is greater than y. So guys, what do you think the result would be? So over here, the first condition evaluates to true because x is obviously not equal to y. Then the second condition is evaluated to false because 10 is not greater than 20. And we get a resultant value of false because one of the conditions is evaluated to false. So this was the AND operator. Now let's also perform some operations with the OR operator. So over here, let me give in the first condition and let me check if x is greater than y. Now let me check. Now let me give in the OR operator and let me give in the second condition. And this time I am checking if x is equal to y. So I get a false result because both of the conditions have failed. So x is greater than y. This gives me false because 10 is not greater than y. And then the second condition also gives me false because 10 is not equal to 20. And thus I get a false value. Now let me perform another operation with OR. So this time let me check if x is not equal to y. I will give in OR operator and the second condition is x is equal to y. So guys, what do you think the result would be this time? So this time we obviously get a true value because the first condition is evaluated to true. So here, even though the second condition is evaluated to false, since the first condition is evaluated to true, the overall result is true. Right, so this is how we can work with logical operators. And these were some of the operators in R. Now let's work with objects. So objects, so every data element in R is identified as an object. And these are the six major objects available in R. So we have vector, matrix, factor, list, array, and data frame. So let's start off with the most basic object in R, which is a vector. So a vector is basically a linear object and it contains only elements of similar type. Or in other words, it contains only homogeneous elements. And this is how you can create a vector in R. So we given the C function over here. So this stands for combine and I am giving in 3 elements all of numeric type. So I am creating a numeric vector. And similarly, let's take this example. So over here, I am using the C function or the combine function and I am giving in 2 elements and both of them are of logical type. So you see that a vector takes in only homogeneous elements. Now let me create some vectors in R. So what I'll do is I will create a vector by the name of my vector and let me use the assignment operator and I will give in some numeric values. So let me give in all the numbers from 1 to 6. Now let me print this, my vector. So guys, this is how a vector looks like. So what I've basically done is I have created a numeric vector which comprises of 6 elements. Now let me verify the class of this. So I will use the class function and I will pass in this my vector object. So you see that the class of this object is numeric. Now to the same object, I will be assigning character elements. So I will give in the values to be A, B, and C. Now let me check the class of this vector. So class of my vector, and we see that the class of this vector is character this time around. Now I will go ahead and create a logical vector. My vector, I will use the C function and let me give in some logical values. So the first logical value is true, the second logical value is false, the third logical value is true again, and the fourth logical value is false again. Now let me have a glance at the class of this. So class of my vector, and we see that this is a logical vector this time, right? So till now what we've done is, to whatever vectors we've created, we have only given elements which belong to a similar data type. Now I'll create another vector where I will pass in elements belonging to different data types, and let's see what would be the result. So again, to my vector, what I'll do is I will pass in some elements belonging to numeric type and some elements belonging to logical type. So I will pass in the first two elements which are of numeric type 1 and 2, and then I will pass in two logical values which are true and false. So guys, what do you think the result would be this time? So let me actually print it and show it to you guys. So what we see over here is the numerical values stay the same. So 1 is 1, 2 is 2, but these logical values have been coerced to numerical values. That is, this true value has been coerced to the value 1, and this false value has been coerced to this numeric value 0. So with this, we basically understand that the numeric data type has greater precedence over the logical data type. And if we ever pass in the numeric values and the logical values into the same vector, then since the numeric vector has greater precedence than the logical data type, obviously the logical values should be converted into numerical values. Now similarly, I will pass in character values and logical values into the same vector. So let me use in the C function over here. So I will pass in two character values first, A and B. After this, I will pass in up to logical values, true and false. Now let me print this, my vector. So this time these two elements are the same. So A and B are characters and they remain as characters, but these two logical values, they've been coerced to character values. So true logical value has been changed to a character true value. Similarly, this false logical value has been coerced to this false character value, right? So again, this tells us that a character data type has greater precedence over the logical data type. And then finally, I will pass in all of the three numeric, logical and character data types into the same vector. So first I will pass in two numeric values, then I will pass in two character values, and finally I will pass in two logical values, true and false. Now let me print this, my vector. So this time what we see is all of the values have been coerced to characters. So this means that character values would have the highest precedence, followed by the numeric values, followed by the logical values. Now let me actually print this vector again. Now let me guide you guys on how to extract individual elements from a vector. So let's say I wanted to extract this fourth element from this vector. So I will give in the name of the vector first, which would be my vector. After that, I would give in two square braces, and then I will give in the index number. And since I want to extract the fourth element from this vector, I will give in 4 over here. And this is how we can extract the fourth element. So similarly, if I wanted to extract the sixth element, all I'll do is I will give in the name of the vector, I will give in two square braces, and then I will give in the index number, which is 6. So this is how we can extract the sixth element from this vector. Now let's say I wanted to extract multiple values from this vector. So let's say I wanted to extract all of the odd elements, that is the first, the third and the fifth elements from this vector. So what I'll do is I will use this C function over here, and I will give in the number, and I'll give in the index values, which are 1, 3 and 5. So we get the element at the first index, the element at the third index, and the element at the fifth index, right? And this time what I'll do is I'll extract all of the elements starting from index number 2, and I'll go on till index number 5. So I will type in my vector over here, and I am extracting all of the elements from index number 2 to index number 5. So for that, I would have to give in the index number, the first index number, after which I will give in colon, and then I will give in the index number till which I'd have to extract all of the values. So that would be 5. So from this my vector object, I am extracting all of the elements starting from index number 2 to index number 5. So this is the result. So I'm extracting all of the elements starting from index number 2 to index number 5. Guys, so that was a vector. So the next object which we are dealing with is a list. So list again is a linear object, but the contrast which is there between a list and a vector is a list can contain heterogeneous elements. So let's take this example over here. So this is the syntax to implement a list. So we will use the list function, and over here we can pass in values. So when we pass in the values, this numeric value will not be coerced to this character value. Similarly over here, what I'm doing is I am creating a list comprising of these two elements, and again we can be pretty sure that one value will not be coerced into the other value, right? So let me go to RStudio and implement some lists. So I will create a new list and name that list to be my list 1, and I will be assigning values to this my list 1 using the list function. So let's say the first element in the list is the numeric value 1, the second element in the list is the character value A, and the third element in the list is the logical value true. So now let me print this and let's see how does a list look like. So my list 1. So this is how a list looks like. So see that there are 3 different components. So the first component has this numeric value 1, the second component has this character value A, and this third component has this logical value true. And each of these values have retained their original identities. So let me have a glance at the class of the list. So class of my list 1. So we see that the class of this object is list. Now let me find out the class of these individual values. So class of my list 1, let's say I would want to find out the class of this value. So this is the first component. So if I want to extract the first component, I will give in 2 square braces, and inside those square braces again I will give in 2 more square braces, and I will give in the component number. So let's say I'd want to find out the class of this first component. So I will pass in 1 over here. So see that this is of numeric type, right? So even though we have passed in a numeric value, a character value and a logical value, the numeric value retains its original identity. Similarly, let me change this and let me put the index value to be 2. So this is of character. Now again, let me change this and let me extract the third component. So this is logical. So even though we have passed a character element and a numeric element into the same list, this true value has retained its original identity, and this is still a logical value. Now let me go ahead and create another list, and I'll name this list to be my list 2, and let me use the list function to give in the values, right? So what I'll do is I will create 3 different vectors as 3 different components inside this list. So let me create the first component, which should be a numeric vector. So this numeric vector has 3 numbers 1, 2 and 3. And the second component would actually be a character vector, and the elements are A, B and C. Now after this, let me create a logical vector, and the values which I am giving to this logical vector are true, false and true. Now let me print this, my list 2. So over here what I'm doing, so over here what we can see is we have 3 different components, and each component inside the list is a vector. So this first component comprises of a numeric vector, the second component of the list comprises of a character vector, and this third component of the list comprises of a logical vector. Now Let's say I'd want to extract this second element from the second component. So let me show you guys how this is done. So I will put in my list 2 over here, and since I want the second component, I will put in 2 braces. Again, I will put in another 2 braces inside this, and then I will give in the component number, which is 2. And from the second component, since I want the second element, I will give in the index value to be 2. And this is how we have extracted this element from this list. So similarly, if I wanted to extract this true element from this third component, so all I have to do is first give in the component number, which is 3. And from the third component, I would have to extract the first element. So I will give in the value to be 1. And voila, we have extracted the first element from this third component. Right guys, so this is how we can work with lists. And after list, we have a matrix. So matrix is actually a 2-dimensional object which contains elements of similar types. And this is the syntax to create a matrix. So we pass in the data, and after passing in the data, what I'm doing is I am specifying the number of rows inside that matrix. And the number of rows which would be there in the matrix is 2. So these are the elements 1 to 8, and these numbers from 1 to 8 are arranged in 2 rows, and this is the result which we'd get, right? So matrix is basically a 2-dimensional object which comprises of rows and columns, and all of the elements in the matrix belong to a single type. Now let me go to R and make a matrix. So I will use the matrix function for this. And first what I'd have to do is give in the data. So I will use in the data parameter, and let me give in the values. So the elements in the matrix should be the numbers from 1 to 8. Now let me hit enter and let me see what do we get. So if we do not specify the number of rows, then this is what we get. So all of the elements are arranged in their respective rows. So this number 1 has been assigned to row number 1. This number 2 is in row number 2, this number 3 is in row number 3, and so on. So if we do not specify the number of rows, then all of the elements would be enrolled into all of the rows, and we would have only one column. So let us use the nRow parameter and specify the number of rows. So let's say I want the number of rows to be 2. So this is what we get over here. So the elements, the data is coming from these elements 1 to 8, and these elements are arranged in 2 rows 1, 2, 3, 4, 5, 6 and 7, 8. But what we see over here is these elements are arranged column wise, not row wise. So if I want to arrange these elements row wise, I have the by row parameter, and I will set the value of this to be true. So we see that the elements have been arranged with respect to row. So initially they were arranged with respect to column. Now they've been arranged with respect to row. So 1, 2, 3, 4, 5, 6, 7, 8, and all of these elements have been arranged with respect to row. Right. So now let me actually store this in a new object and name that object to be mat1 and print the value of mat1 over here. Now let's say I would want to extract this element from this matrix. So the element is present at second row, third column. So to extract the element present at second row, third column, what I have to do is I'd have to give in the name of the object. Then I will give in square braces. Now inside the square braces, first I will give in the row number, which would be 2. Then I'll put in a comma. After that, I will specify the column number, which is 3. So with the help of this, I can extract the element which is present at row number 2 and column number 3. And we have successfully extracted this element present over here. So similarly, if I wanted to extract these 3 elements from this matrix, so what I'd have to do is given the name of the matrix, and I will use in the combine function over here, and I will pass in the row number over here. After passing in the row number, since I want to extract the elements present at the first column, second column and the third column, I will specify those column numbers. So that would be 1, 2 and 3. And this is what we've got. So from this entire matrix, I have extracted the elements present at second row first column, second row second column, and second row third column. So this is how we can work with the matrix in R. Then we have an array. So array is basically an extension to a matrix. So arrays are homogeneous objects which can have more than two dimensions. That is, all the elements inside an array belong to the same data type, but the only difference between an array and a matrix is arrays are objects which can have more than two dimensions, but matrices can have only two dimensions. And this is how we can create an array. So we'll use the array function. Now inside this array function, I will pass in the data from which the elements will get their values, after which I'll specify the dimensions. So this dimension value of 3, 3, 2 basically tells us that we are making two matrices of 3 cross 3. That is, there are two matrices where the number of rows are 3 and the number of columns are also 3. So let me go ahead to RStudio and implement this. Right. So let me create the first vector over here. So I will name that vector to be v1 and let me pass in the values. So let's say vector 1 consists all of the numbers from 1 to 8. Now I will create another vector, and inside this vector I will pass in all of the numbers from 9 to 16. So we have our two vectors ready, and we'll be taking the elements from these two vectors. So let us go ahead and create our array. So I will type in array because this is the function which helps us to create an array. Then we'll pass in the data. So the data is coming from vector v1 and vector v2. Now after getting the data, let me specify the dimensions. And to specify the dimensions, I'll be using the dim parameter. Now let's say I would want two matrices where the number of rows are 2 and the number of columns are 4. So let me give in the number of rows which are 2. Let me give in the number of columns which are 4, and let me give in the number of dimensions or the number of matrices which are 2. Let me hit enter and let's see what do we get. So guys, this is the result. So we have two matrices, or in other words, we have two 2 cross 4 matrices. So the first matrix has 2 rows and 4 columns. Similarly, the second matrix also has 2 rows and 4 columns. So the first matrix gets its elements from vector v1, and the second matrix gets its elements from vector v2. Now let me store this in a new object arr1. Let me print arr1 over here. So now let's extract individual elements from this array. So let's say I'd wanted to extract this number 13 from this entire array. So for that, I'd have to give in the name of the array. Then I will give in square braces. So this element is present in the second matrix, and the row number is 1 and the column number is 3. So first, let me give in the row number, which is 1. After that, let me put in a comma, and then I will give in the column number, which is 3. And then finally, I will specify the matrix number, which is 2. So I am extracting the cell number 1, 3 from the matrix 2. Right, so we've got the result. Now, similarly, if I wanted to extract this entire second row from the second matrix, so let's go ahead and do that. I will pass in arr1 over here. Now, inside this, what I'll do is, since I want the entire second row, I will put in 2 over here. And since I want to extract all of the columns, I will not specify the column numbers. So if I don't specify the column numbers, then this would give me all of the columns with respect to that row number. And since I want this rows from the second matrix, let me give in the value of the second matrix, which would be 2. Right. So this is how I have extracted the entire row from this matrix over here. So this is how we can extract individual elements from an array. So that was an array. Now let's go ahead to the next object, which is a factor. So as you can see over here, factors are basically objects which are used to categorize the data. So let's take this example over here. So we have a character vector comprising of male, female, female, and male. So these are the elements, but what we see over here is there is actually repetition of values. So the value male is repeating twice, and also the value female is repeating twice. So this basically means that there are two categories inside this character vector, and wherever we can find categories, we can use the factor function and convert that character into a factor. So this would help us to create categories out of these character vectors. So let's go to our studio and make some factors. Right. So what I'll do is I will use the repeat function and repeat three basic values. So I'll be repeating x, y, and z. So I have three values x, y, and z. So this is a character vector comprising of these three elements, and I am repeating these three values 5 times. Let me hit enter, and this is what we get. Right? So x, y, z, x, y, z, x, y, z, x, y, z, and x, y, z. So we are repeating this vector 5 times. So we have the same element 5 times. Now what I'll do is I will store this in a new object and name that object to be my data. Right. Now let me have a glance at the class of this. So class of my data. So you see that the class is character. Now let me go ahead and use the as.factor function and convert this into a factor. So as.factor of my data. So these are the original elements and these are the levels. So we have successfully converted this character vector into a factor vector, right? So we have 3 different levels over here, or 3 different categories over here, which are x, y, and z. And finally, we have the data frame object. So data frame is basically a 2-dimensional structure which can comprise of heterogeneous elements. So in a data frame, the columns contain only the homogeneous elements, but the rows may or may not contain heterogeneous elements. And this is how we can create a data frame. So we'll use the data.frame function, and inside this we are creating 2 columns. So the name of the first column which I'm giving is name, obviously, and the values which would be there in the first column are Sam and Bob. After that, I am creating a new column age, and the values which would be there in the second column are 32 and 48. And this is the result which we'd get. So we have basically created a data frame where we have 2 columns and all of the column values have the same data type, right? So these 2 values have the same data type. Similarly, we have this age column over here, and these 2 elements have the same data type, right? Now let me go back to our studio and create a data frame. So I will use the data.frame function, and let me give an so what I'll do is I'll create a data frame where I'll have one column which would have the names of the fruits and another column which would have the cost of the fruits. So I will name the column, the first column, to be fruit name, and I will give in 3 values. So the first fruit would be apple, the second fruit would be mango, and the third fruit would be orange. Then I'll go ahead and create the second column, which would be fruit cost, and the cost of these fruits are, let's say, 105, 57, and 80. And I will store this in a new object and name that object to be fruit. So now that we have created our data frame, we can visualize our data frame with the help of this view function. So I will use the view function. I'll pass in the data object, which is fruit, right? So we have our data frame right in front of us, and this comprises of 2 columns, fruit name and fruit cost. So we have 3 different fruits over here, apple, mango, and orange. And this is the cost corresponding to these 3 different fruits. So apple costs 105 rupees, mango costs 57 rupees, and orange costs 87 rupees. So this is our data frame. Now let me show you guys how can we extract a single column from this data frame. So to extract a column from a data frame, I would have to give in the name of the data frame first, and then I will give in the dollar symbol, after which I will give in the column name. So let's say I would want to extract this fruit name column, then I will select fruit name. So from the fruit data frame, using the dollar symbol, I am extracting the fruit name column. And we have successfully extracted this column from this data frame. Similarly, if I wanted to extract this fruit cost column, all I have to do is given the name of the data frame first, which is fruit, then I'll use the dollar symbol, then I will use the name of the column, which is fruit cost. Now let me hit enter, and this is the cost of the corresponding fruits. So this is how we can extract individual columns from the data frame. Now let's see how can we extract individual values or individual cells from this data frame. So again, for that I would have to give in the name of the data frame first. I will put in 2 square braces, and let's say I would want to extract this cell value from this data frame. So this is present at row number 3, column number 2. So first I will give in the row number, which is 3, then I will give in the column number, which is 2. Right, so you have extracted this value, and let's say if I wanted to extract this entire second row, so what I'll do is I will give in the row number, which is 2, and since I want the entire second row, or in other words I need both of these columns, so I'll not specify anything in this column index region over here. So I have extracted this entire second row, which is mango, the name of the fruit, and the fruit cost, which is 57.